At this point, we can move to a fun part of the build where we put together the receive detector circuitry. So I just got the schematic blowout of the receiver circuitry here, and it consists of three primary parts. There's an RF splitter here which takes the signal from the antenna, you see RX ant here, and it splits it into two identical signals 180 degrees out of phase with one another. It also has the Taylor quadratary sampling detector here, implemented by an FST3253 multiplexer demultiplexer. And then finally there is a preamp here, which is implemented using an LT6231 op amp. So both these devices here are SMD devices, and I'll go through where they are on the circuitry. The only really tricky part of the build is is T5, the RF splitter. That's the and so what I'll do is I'll kind of demonstrate how to wind that and how to install it on the circuit itself. As to where these components take up, so here's T5 right here. So this part of the circuit around here consists of the RF splitter. And then if you look on the reverse side of the circuit, we have here and here. This is where the FST3253 goes, and this is where the op amp goes. So there's some associated capacitors, SMD capacitors there too. So after this part of the circuit is built, we'll be able to get the radio on the air. Now, as I mentioned before, this is a radio that requires you have some form of SDR software on your PC to run it. I have HD SDR, so I'll be using that. But before I do that, what I'll do is I'll test the circuit by injecting an RF signal and confirming that we do get the I and the Q audio signals on the output. So anyway, next part of the build is I'll wind together T5, that RF splitter, and we'll show how that gets installed in the circuit. So we've actually got two toroids to wind. There is L4 here, which is a T25-6 with 17 turns. And then we've got T5, the transformer, which is the splitter as I mentioned before. And that has 14 turns on the primary, and then bifilar 7 turns on the secondary. So I'll get started with winding the L4, 17 turns on a T25-6. For those who haven't seen a T25-6 before, it's quite small. Here is one here. So not too bad to wind, a little bit fiddly. But anyway, I'll get started with L4 and then move on to T5. So so L4 is complete. Now I'll start working on T5, the transformer. So the first thing I'll do is wind the primary, which is 14 turns on the T25-6 here, and then we'll come back and do the bifilar windings for the secondary. So I've wound the bifilar winding together. So this is just basically a loop of number 30 wire and then tightly twisted together. So you can see there's about probably 10 turns per inch there. So what we have to do now is just basically wind 7 turns in the same direction as the primary winding on the toroid. So let's get going with that. So there's the finished transformer there. It's a little hard to count the windings on there, but it is 14 and 7. One of the things I like to do with this is, with the bifilar windings, keep them at a different length. That'll come in handy later on when you're trying to identify which wires belong to which spot. So that'll be the next step, is to basically untwist the bifilar windings. So we'll actually have 6 leads coming off this transformer, and then we'll take the enamel off them, and then for each lead we'll figure out which is which. I mean, obviously these two are the primary, but now we've got to figure out which is the start and finish of the secondary windings. So that's next. So I finished winding T5 and stripping the enamel off the 6 leads there. So you can see why I kept the primaries short now. It's easy to identify the primaries from the secondaries. So these 2 windings here are the primaries, and then these 4 are the secondaries. So now we've got to find out which of these secondaries goes with which of the secondaries. So we're looking for continuity here. So let's first probe these 2 secondaries here. I'll make sure I get the right wire here. So no continuity there. And we have continuity there. And let's probe this one here. So continuity and continuity. So this secondary goes with this secondary, and this secondary goes with this secondary. So we have to swap those 2 over. So let me just do that. You've got to keep careful while you're doing that, you don't accidentally touch the 2 secondaries together. So now we can see we should have continuity from here over to here, which we do, and now continuity from here to here. And there we go. So here's the 2 primaries, and then here's the 2 pairs of secondaries. And now we'll move on to installing it on the board. So now we've got our transformer sorted out and ready to go. It's time to install it on the board. And where it actually goes on the board is right here. And the order of the pins here is, this is a pair of secondaries, this is a pair of secondaries, and then this is the primary down here. So our 2 short wires go into these holes, and then the pairs that we selected that had continuity go into here and here. Now it doesn't really matter which secondary goes into where, so long as the pairs that have continuity go into the pairs of holes from here to here and from here to here. So let's get the transformer out. Bear with me. So let's start with the pairs of secondaries at the top here. So I'll put that right in here. This is kind of fiddly as you go through this. Doesn't help. My eyesight isn't great, so I have to sort of really peer into this here. So there's 1 pair of secondaries in. Let's get the second pair of secondaries in. And then we just push that down till we've got enough room to get the primary in. Alright, now we get the primaries in the final hole here. Excuse my hand is right in the way here. So let me pull back here so we can actually see it installed here. So we've got the 2 pairs that had continuity. This pair has continuity. This pair has continuity, and then the short ones, as we saw, are the primaries. So that's how it gets installed. I'll basically pull it through and get it soldered in, and then come back. Okay, so there's the transformer installed. Now, really you have to get those secondaries sorted out before you install it. Because of the way the circuit is organized, all the secondaries actually have continuity after you've installed it. So let's just probe around. You can see here all of these now have continuity, so you can't really install it and then figure out did you get the secondaries right. You really have to figure that out before you put in. So anyway, we'll move on to the remainder of the circuit, installing L4, and then I'll skip quickly through the rest of the installation, including the FST 3253 and the op amps and the various resistors and capacitors, like I've done in the other videos. So I have the receive circuitry all installed and in place. Unfortunately, we aren't quite ready to be on the air. I forgot in the last video that in order to get on the air, we have to install the low pass filter here, and there's a B and C adapter I have to install. So we'll do that next, but we can test at the moment. So let me just explain the test setup I've got here. So if I just pan up a little bit. So what I'm doing is I'm injecting a 14.050 megahertz signal right here into antenna in. So here's my signal generator over here. So you can see that's set to 14.050 megahertz, and that's simulating a signal on the air. So I've got the synth tuned to, just panning over here, I've got the synth tuned to 14.050200 megahertz. So we should actually see on the oscilloscope a 200 hertz signal out on the I and the Q output here. So at points 2 and points 3. So if I just pan into the oscilloscope, you can see it's close. It's about 300 hertz rather than 200 hertz. I actually think that's an error in the signal generator. I think it's about 100 hertz out. So I'll have to look at how to calibrate that signal generator later on. So notice also these two signals, these two audio signals are in quadrature with the yellow signal leading the purple signal by 90 degrees. Now what I can do is if I alter the frequency, this is the tuned frequency to below the 14.050 signal. Let me just do that now. You'll see at a certain point it goes to DC. That's exactly the transmit the RF frequency. But then if I go below that signal, you'll see now the purple signal is leading the yellow signal. So let me do that again. So if I go above, see there the yellow signal is leading the purple, and if I go below, now the purple signal is leading. So basically this is what the SDR software uses to determine whether the received signal is above or below the tuned signal. So that's the basis of an IQ receiver. So that's basically the receive circuitry built together. What I'll do in the next phase is put the low pass filter in and the B and C adapter, and then we'll see if we can actually hear something on the airwaves with this receiver. I will also take you through at least, I haven't got HD SDR installed on my laptop here, so I will take you through the installation. There's just some simple files you have to copy into the HD SDR directory to enable the config software. So that's all for now. Next step is building up the low pass filter, the B and C adapter, and then we'll see if we can get this on the air.